Okay, let's look at what we're going to do next. The next thing we're going to do is we're going to machine this edge here. Now, our print here says it needs to be parallel to D within 2 thousandths. Well, where is datum D? Oh, datum D is way up here. See that? That is actually this side. Didn't we call that side B? We did call it side B. But here's why it's not datum B. Datum B, see this little triangle right here? Notice how it's right across from this dimension, this 1.875 dimension? That 1.875 is datum B, and this side is datum D. So we need to concern ourselves with this 1.875, and the tolerance on that, because it's a 3-place decimal, is called out down here in the tolerance block. So a 3-place decimal is plus or minus 5. So this side needs to be parallel to this side within 2 thousandths, and this dimension across here has to be 1.875 plus or minus 5. Okay, so the next part of this project, I want you to take an angle plate, and I want you to mount an angle plate to the table. We're going to clamp this down to the table. Now, when you clamp this down to the table, we're going to use strap clamps. And when we use a strap clamp, we're going to use a heel block on this. And the strap clamp, we actually want that strap clamp to come down onto the part so that the majority of our force is pushing down here. So what we want to do is actually have this part up just a little bit higher than the front end of the clamp. And this will actually just be bolted straight down to the table. Pull that down tight. We're going to indicate the face long ways, and we're going to also indicate that face straight up and down to make sure that that angle plate is true to the table. We're going to take our block and we're going to C-clamp it right here to the angle plate. We'll throw a parallel up underneath this side. Now, datum A is right here, and datum D, the last surface that we milled, is right here. And so we're going to clamp this up, and we're going to mill this side off. We're looking for it to be parallel within 0.002 to D. And at this point, we're also going to bring it into size, and that size is going to be 1 inch, 0.875 plus or minus 0.005. And we'll check that using micrometers, and we'll be able to see that it's both parallel, and we'll be able to see that it's in tolerance. We were talking about clamping down this angle plate. Now what I'm going to do is I'm going to take this clamp, and what I'll do is I'll hold the clamp down on one side, and I'll bring the step block so that it's flat against, and this is about where I should be bolting this down. My stud should go as close to the workpiece or as close to the end of the clamp where we're going to bolt this down. Again, we want to use a washer, and we'll put a nut on it, and we'll tighten this down. So now let's set this angle plate up. So now we're going to indicate this angle plate just like we would a vise. We're going to start off zeroing out. We've snugged down this clamp here, and we're going to set this. We've set the indicator to 0. We're going to move to the other side of the part. We're going to tap our angle plate until we get it to read 0. We're going to run back and forth across this part a couple of times before we bolt it down. Now we're ready to snug this down. And now we want to check the angle plate for square up and down, and we do that simply by running the indicator across the face of this. We want everything to be less than 1/1000th on this face. So now we've got our part clamped up. We've got a couple of parallels up underneath here. We tapped it down using the soft hammer. We made sure that those parallels are tight up underneath here, and we clamped this part down. I like the can twist clamps, but you can use any kind of clamp you want. And now to verify that this part is indeed parallel to the table, I've taken a surface gauge and I've set my indicator on here. And we're going to check this, check the part. Pretty fussy. Just by moving from side to side across here. And I see that it's a little bumpy, but I can see that I'm getting a real good surface across here. I must have hit a little chip or something on the table, but it's looking pretty good back and forth across here and across that entire surface. So now I'm ready to take the cut. So now I'm ready to start making my cuts. I'm going to use the 2-inch carbide end mill with this, but you can use the high-speed steel if you want. I'm going to touch off on my workpiece, and I know there's about 125 thousandths to come off this part, so I'm going to take half of it. I'm going to take 65 off of here. There's 60, there's 65 right there. Now my next cut, I'm going to bring it right into size. Now because I'm using the carbide end mill, because I'm taking 60 thousandths, 65 thousandths off of here, I'm going to run this, treat this as if it were a roughing cut. So my speed is set for a roughing speed, and my feed rate is going to be that of a finishing cut because I do want it to be a finishing cut. I'm going to measure this cut, and then I'm going to adjust to the size of the part that I want it to be. Notice the cutter is cutting into the workpiece, pushing all the force against the angle plate in the back. I'm going to make sure that my clamps are tight and I'm ready to go. Got my speed. Shut the spindle off, make sure it's stopped, and I'm going to measure my part. Now, remember I said we can check it for parallel, so the first thing I'm going to do is we're going to measure this. And I'm reading 925, 924, 924 and a half. You might have to come around to the back side of the part here to measure this. We're getting 924, 924. So we're going to 875. So I've got 49 thousandths to come off this part. We'll turn the cutter back on. We'll come back to the other side of the part. We said 49 thousandths. I'm going to bring this up 49 thousandths. There's 10, 20, 30, 40, 49 thousandths. So I want to make sure that my table's locked in the cross slide and the up-down direction. Now we're ready to go ahead and take this final cut. Now this is our finished cut, but it's also considered a roughing cut because it's down pretty low. Check your surface finish. Surface finish look okay? Should. And we'll check the dimensions before we remove it from the block. We already know that the tool was cutting nice and parallel, so we're not going to have to worry about measuring this in a bunch of different spots. And we're measuring 874 and a half, well within our tolerance range. So now we're going to take it off the angle plate, deburr it, we're going to take it over the surface plate and inspect this. Okay, so now we're going to inspect this part. We've gone ahead and we've deburred it. We're going to place side D down flat on the table, and we're going to bring the indicator over, zero out the indicator, and we're going to run this entire part under that indicator, and we see that there's less than 1,000th run out on that indicator. So being parallel within 2 is well within tolerance here. We mic this part. Right here I'm coming up 1 inch 874. Again, that's well within tolerance. So now we've completed 3 sides of this. We have the A side, we have the D side, and we have the side opposite that. The next step is we're going to finish this side.